Next we have the effect of substituents on the acidity of carboxylic acids. How the substituents can affect the strength of carboxylic acids. We know that already we have studied in the previous chapters, minus I groups are known as electron withdrawing groups. So, electron withdrawing groups always increases acidity, and minus I groups, that is electron donating, or we can call it as electron releasing. So, minus I or electron donating or electron releasing substituents will decrease acidity. Now, why the minus I or how the minus I group increases acidity? Because they stabilize the carboxylate ion. So, minus I groups increases acidity by stabilizing the carboxylate anion, and plus I groups decreases acidity by destabilizing the carboxylate anion. These are the two value points coming on the effect of effect of substituents on acidity. Now, the most important point is the effect of substituent, whether it is plus I or minus I, the effect will decreases when the distance from the carboxylic acid group increases. And the order of the effect of substituent is, it is clear from this order. When we consider halogens, fluorine, chlorine, bromine and iodine, if there is fluorine atom, such acids will be more acidic than chloro acids, than bromo acid and iodo acid. Now, if there is a nitro group, that acid will be more acidic than a halogen containing acid. And if there is more than one fluorine atoms present in an organic acid, that will be most acidic in nature. So, this is the order of acidity of different substituents. Now, we will see few questions. The question is to identify which is more acidic and write the reason. Identify the one which is more acidic and write the reason also. The first question is CH3COOH or CH2Cl-COOH. Acetic acid or chloroacetic acid, which is more stronger? The answer is chloroacetic acid, and the reason is due to minus I effect of chlorine. Due to minus I effect of chlorine, it stabilizes the corresponding carboxylate ion. Now, the second question is chloroacetic acid or fluoroacetic acid, which is more acidic? Answer is fluoroacetic acid, and the reason is due to high electron negativity of fluorine. Due to high electron negativity of fluorine. Next question is benzoic acid or 2-phenyl-ethanoic acid. We know that it is clear from the box, if there is a benzene ring or phenyl group, the acidity will increase. But in both these compounds, we can see benzene ring. But which is more acidic? We already studied one more point. When the distance from the substituents increases, effect will decrease. So in this, COH is directly attached to benzene ring, but here it is not directly attached. It is little bit far away from carboxylic acid. So more acidic will be benzoic acid because COH, the reason is COH group is directly attached to benzene ring. COH is directly attached, here it is far away. Next question. Benzoic acid or 4-methoxybenzoic acid, which is more acidic? Yes, it is clear from the structure that here there is one methoxy group, and we know that the methoxy group is plus psi or electron donating. Already we have studied about the plus psi and minus psi groups. Again, I don't want to write here. So we know that methoxy group is plus psi or electron donating. So such groups will decrease acidity. So here more acidic. The question is, which is more acidic? So here more acidic will be benzoic acid. So why this is less acidic? Due to the plus psi effect of plus psi or electron donating effect of OCH3 group. Write the reason also. Next question. Benzoic acid or 4-nitrobenzoic acid. Yes, we know that nitro group is minus psi or electron withdrawing, but here there is no plus psi or minus psi group. So due to the presence of minus psi group here, the answer is 4-nitrobenzoic acid is more acidic due to the minus psi or electron withdrawing NO2 group. Now the next question is, (2-chloropropanoic acid or 3-chloropropanoic acid? 2-chloropropanoic acid or 3-chloropropanoic acid, which is more acidic? The reason is, the answer is, if there is halogen atom present in both the compounds, the halogen atoms are same, and if a halogen atom is present, acidity will increase, but if they are close to COH, acidity will be very, very high. So answer is 2-chloropropanoic acid. Now very important question, when COH group, if it is attached to vinyl group or phenyl group, they are highly stabilized or they are more acidic in nature. For example, if a COH group, if it is attached to a vinyl group means CH2 double bond CH. If a carboxylic acid group, if it is attached to vinyl group, what happens here is COH group, it is attached to, we know the hybridization of this carbon is sp2. So sp2 hybridized carbon is always more electronegative. Similarly, if a carboxylic acid is attached to phenyl group or benzene ring, so here also COH is attached to sp2 hybridized carbon. So in vinyl or phenyl group, COH group is attached to sp2 hybridized carbon. Since the sp2 hybridized carbon, they are highly electronegative, acidity will be more. So, the reason for the high acidity of vinyl or phenyl group or which is attached to COH group is the high electronegativity of sp2 hybridized carbon to which they are directly attached. COH group is directly attached to an sp2 hybridized carbon. Here also COH is directly attached to an sp2 hybridized carbon. So, this is a very important question. Higher acidity of vinyl or phenyl group. Now, there is one more question. To arrange the following compounds in the increasing order of acidity. The compounds are benzoic acid, arranged in the increasing order. Compounds are benzoic acid, 4-nitrobenzoic acid, 3,4-dinitrobenzoic acid, 4-methoxybenzoic acid. These are the compounds given. We have to arrange these compounds in the increasing order of acidity. So, from this question it is clear that benzoic acid, there is no other functional groups present. In nitrobenzoic acid there is one nitro group. In 3,4-dinitro we have two nitro groups, and here we have methoxy group. Methoxy group is minus I or electron releasing, so it will decrease acidity, but nitro group will increase acidity. So, we have to write the least acidic one, that is 4-methoxy is least acidic due to the plus I effect of methoxy group. Then next comes benzoic acid, because there is no plus I or minus I group. Then next comes (4-nitrobenzoic acid), and last comes 3,4-dinitrobenzoic acid. So, why 3,4-dinitrobenzoic acid is more acidic? Due to the presence of two nitro groups which are minus I or electron withdrawing. So, these are the effects of substituents on the acidity of carboxylic acids.